Hi everybody. I'm going to walk through number 3 from the practice we were looking at. So you can see I kind of have a picture drawn here and I have some stuff labeled on there. I also have a force pushing to the right at the center of the circle, and I have the earth pulling down there. And I also would probably put a force from this floor here pushing up, but once this thing starts rotating, that floor force is going to disappear, so I'm just going to leave it off. I also think that once this thing starts tipping up the stair, that it's going to rotate around this point. So that is going to be my pivot point. Now, before I get into that, the problem asks us to prove that this distance here, that didn't come out very well, was, I think it was root, now I'll just figure it out. If you look right here, this distance has to be r because I'm going from the center of the circle to the edge, so that's r. So I'm going to take this and make a little triangle up here. So this triangle is really right here. That's r. The vertical part of it is r minus h. And so what is this part? Well, we can just use Pythagorean theorem to figure that out. R squared's got to be equal to r minus h squared plus question mark squared. So r squared minus r minus h squared equals question mark squared. And now I can just simplify this. R squared and that goes away. We've got h squared minus 2rh equals question mark squared, and if I square root both sides, this value right here is this side of the triangle. And so we proved what the question asked us to prove. So I'm just going to write that here now and then erase the rest of that. And I could simplify it a little bit further, but I'll just leave it like that. Alright, so how does that help us? Well, we'll see here. Let me get rid of this. Now, I told you earlier that I think this is going to rotate around this pivot point here on the corner. So that's my pivot point. I've got this, this is sort of the radius right here, r. And I'm just going to redraw this over here. Got r coming up there. There's a force from the person, and then the earth is pulling down. Here's my pivot point. This is r. Alright. So, what do I have to do here? Well, I know that this thing's going to start rotating as soon as the torque from the person is a little bit bigger than the torque from the earth. So I'm actually going to first solve for when are they equal, and then I'll just say anything more than that for the person would make this thing start tipping. So I'll sum up the torques here. Sum of the torques. I need an angle here. So I have minus f times r times the sine of theta is the torque from the person, and then plus mg times r, and the smallest angle right here, I'll call it theta 2, is the smallest angle between mg and r is theta 2. That's got to be equal to 0. Now, this is kind of a problem here, because I have a bunch of unknowns here in my equation. This is an unknown, that's an unknown, and that's an unknown. And I can't really solve an equation if I have 3 unknowns. But I think I have an idea on how I can get this equation down to just one unknown. So let's look back up here at this triangle. Let's look at the triangle and relate it to this diagram. Do you kind of see how this triangle right here shows up actually kind of like right there on my diagram? So really this angle here, that didn't show up very well, looks like it's theta 2. So looking at my triangle here, I could actually write out that the sine of theta 2, I'll go back to black here, the sine of theta 2 is opposite over hypotenuse, so that's the square root of h squared minus 2rh over r. And look what I can do here. I can just take this or this and plug it right down in here for sine of theta 2. And all this stuff here is actually a known information. Likewise, I think I can do this with theta. This angle is actually theta. If you look at my picture here, this triangle kind of shows up right there. So that's theta. Oops, that's theta. And so is this angle right here. So I can write a sine of theta as well. I'll do it over here. Sine theta is opposite over hypotenuse, so that's r minus h over r. And I can take that and plug that in right down here. So let me rewrite this, plugging in those values for sine theta and sine theta 2. Watch what happens. Minus f times r minus h over r plus mg r times that mess h squared minus 2rh all over r, and that's all got to equal 0. So you should notice right away that the r's cancel out, and in my equation I have one unknown and I can solve for the force. Now once I get this value, just make it a little bit bigger and then the wheel will start to tip. Hope that was helpful.